Next is the properties of integrals, because to solve an integration problem, the properties help us very much in proceeding with the steps. So let's see each and every property of integral to understand the solving process of integration more better. Say for example, I have two functions f1x, f of x plus or minus g of x dx. So when I'm adding or subtracting the two functions, I get the integration which can be split separately out here. So integration is split accordingly with f of x and g of x. And the second property is, if I have any constant k multiplied to the function, then that constant can come out freely out of the integration. Because the multiplication of the constant does not affect the integration process. So these are the two properties of integration which we take into account when we solve some of the problems. Now continue from the session. If suppose there are n functions and n constants, say for example, I would like to find integration of a1 f1x. Whole of dx, then this is split accordingly with each of the term, because splitting the sum of integration is not restricted only to two functions but to infinite number of functions. Here n different functions. So I can split this as a1 f1x plus or minus a2 f2x plus or minus integral an f(x), which can be split as different integrations out here. Now again, the constant which does not affect the integration can be taken out, and I get is how we understand the splitting of the integration for infinitely many functions. Is how we understand the property of integration. Now let's see the special cases where if I want to find integral dx, then what is the value of integral dx is the biggest question. Now as we know that integral and derivative get cancelled, therefore integral of dx is always said to be x plus c. Derivative of integral of dx is x plus c. Similarly, if I have integral of 0 dx, then this is how much is the biggest question. So in this case, integral of 0 dx is assumed to be the constant of integration c, is how we understand the concept. Next, if I wanted to find integral of mod x dx, then what would be the value of integral mod x dx? Now that implies mod x is plus or minus x is what we have. Substituting for mod x, I get plus or minus x dx. That implies that is equal to plus or minus integral x dx. Plus or minus integral x dx is x squared by 2 plus c, Therefore, integral mod x dx is plus or minus x squared by 2 plus c is what we get as special cases of integration connected with the special cases of the functions. Integral dx is x plus c. Integral 0 dx is c, the constant of integration. Integral mod x dx is plus or minus x squared by 2 plus c. Is how we understand the concept. Let's do some practice problems to understand integration more better. So for example, I have to find integration of x squared minus 2x plus 5x cubed minus 1 of dx. Then this integration, always we need to remember that before we proceed with integration, there are two things which we need to take in mind. One is the standard formulae which we have seen just now, and the properties of integrals which we have considered in the previous session. The standard formulae and the properties of integrals make us get the answer for this problem in a stepwise process. So let's see how we can get the answer for this question using the formulae and the properties. So as we know that integration can be split in plus or minus, I first split each of the terms out here. So this is how I split each of this, and this dx. Now we know that integral of x power n dx is x power n plus 1 by n plus 1 is the formula which we have discussed in the standard formulae. So using this, initially I just split all the constants out because constants are independent of integration in multiplication, so they can be taken out. So this is what we get. And then using the formula here, n is 2 because x squared, n replaced with 2 gives us x power n plus 1 by n plus 1. N plus 1 by n plus 1. And here n is 3, so I get this to be 3 plus 1 by 3 plus 1. And this is integral dx is x, as we know, as a special case. So no dx after integration, because integration is only for dx, but once integration is substituted with formula, there's no dx down. And of course, the constant of integration should not be forgotten, because every indefinite integral when simplified has plus c compulsorily. So this 2 gets cancelled, and therefore integral of x squared minus 2x plus 5x cubed minus 1 of dx is given by x cubed by 3 minus x squared 5x power by 4 minus x plus c. Now rearranging them in order, is what we get as integration of this is this, using the properties and the formulae. Now next, let's see how we can use division process in solving the integration problems. So here I have integral of x power 6 minus 1 by x squared plus 1 dx, which I need to simplify. So x power 6 minus 1 by x squared plus 1 can clearly be divided using the remainder theorem, a equal to bq, the division algorithm, a equal to bq plus r. So let's divide the polynomial this with x squared plus 1. Now clearly we know that this, when multiplied with x power 4, gives x power 6 plus x power 4, which on subtraction gives this minus 1. And then this, when multiplied with minus x squared, gives minus x power 4 minus x squared, which on adding gives x squared minus 1. And therefore this on adding gives us 1 times of x squared plus 1, which gives minus 2 as the remainder. Therefore this term can be written as by x squared plus 1. So we get this as minus 2 by 1 plus x squared. When I split this into the mixed fraction, this plus this divided by this is what I get on simplification. That implies integrating on both sides, I get this to be integral of dx, which on splitting gives us integral x power 4 dx minus integral x squared dx plus integral 1 dx, which is dx, minus 2 times integral 1 by 1 plus x squared dx. Splitting the integration and taking all constants out, I get this. Then using the standard formulae, we have two standard formulae, whereas integral x power n by n plus 1 and integral 1 by 1 plus x squared is tan inverse x, which are the two formulae I'm going to use here. So n being 4, n x power 4 is x power 4 plus 1 by 4 plus 1 minus 2 plus 1 by 2 plus 1, and integral dx is x, because we know this as the special case integral dx is x, minus 2 times integral 1 by 1 plus x squared dx is tan inverse x plus c, is what we obtain for integral x power 6 minus 1 by x squared plus 1 of this is how we do using the division process, and then finding the integration becomes easy. Now next is the using expansions. Let's see how sometimes we need to expand and then we get the integration using expansions. Say for example, I have here two of the expansions factors which I'm going to split through expansions. That is, initially I see that I need some expansions here, that is, this is in the form a plus b whole square. So I use the formula a square plus 2ab plus b square is what we get as a square plus 2ab plus b square times x minus 1 dx. Now this x get cancelled and I get this to be integral x squared plus 1 by x squared plus 2 times of x minus 1 dx. Now further, this and this are two factors which I'm going to multiply to reduce that into a single term. So this on expansion gives x squared multiplied with x is x cubed minus x squared plus x by x squared minus 1 by x squared plus 2x minus 2 whole of dx. This on further simplification reduces to x cubed minus x squared plus 2x minus 2 minus 1 by x squared dx, and hence I'm going to split the factors, that is integral x cubed dx minus integral x squared dx plus 2 integral x dx minus 2 integral dx integral 1 by x squared dx is what we get when I split the integral with respect to each of the terms. Now integral x cubed is using the formula x power n is n plus 1 by n plus 1. This is x power 4 by 4 minus x cubed by 3 x squared by 2 minus 2x minus integral 1 by x squared I can write as x power minus 2, which is 1 by x squared, and therefore n is minus 2 plus 1, so I get n plus 1 by n plus 1 plus c. Your n is minus 2 in this case if I reduce that into the form. This is minus of minus plus of c is how I understand the integration of this function is this, using the expansion of a plus b whole square multiplied with the factor. The product of two factors on integration, it gives us the answer as x power 4 by 4 minus x cubed by 3 plus x squared minus 2x plus 1 by x plus the constant of integration c. Suppose I have the function which has to be integrated as x squared minus x root x plus 3 plus x power 1 by 3 by of dx. Now this has the fractions with numerator and denominator, where in case of these kind of problems where there's only one term in the denominator, we think of splitting the fractions. For these kind of problems where there's only one term, let's see how I can split the fractions. X squared by x power 5 by 2 minus x root x by this plus 3 by this plus this of dx is what we get. Now this on further simplification gives a power m by a power n is a power m minus n, and therefore this gives us 2 minus 5 by 2, and x root x is x power 1 by 2 by x power 5 by 2, and this gives 3 times x power minus 5 by 2 plus this minus this on this. That is, by using a power m by a power n as a power m minus n as the law of index. Now this on further simplification gives 4 minus 5 is minus 1 by 2 minus x power 3 by 2, that is 1 plus 1 by 2, because a power m times a power n is a power m plus n. So 1 plus 1 by 2 is 3 by 2 minus 5 by 2 using this formula. Plus 3 times this plus x power 2 minus 15 of this. Now this, on splitting the fractions, I get x power minus 1 by 2 dx minus x power minus 1 dx on LCM plus 3 times of this dx. Now this, on simplification, gives x power integral x power n dx is x power n plus 1 by n plus 1 plus c. So using this, I get n plus 1 by n plus 1 minus, this is integral 1 by x, which I have is log x plus c, and therefore integral 1 by x is log x and plus 3 times x power minus 5 by 2 plus 1 by minus 5 by 2 plus 1, and then plus x power minus 13 by 2 plus 1 by minus 13 by 2 plus 1 plus c is what we get when we integrate each of the functions out here. So continued from here, I get this to be x power half by half and minus log x plus 3 times of x power minus 3 by 2 by minus 3 by 2, and this reduces to x power minus 13 plus 2 minus 11 by 2 plus c, which on further simplification gives us this 2 comes to the numerator as 2x power half minus log x, and 3 cancel, is what we get as integration of the given problem. On simplification gives this. So therefore, when we have a single term in the denominator, we think of splitting the fractions and then integrating each of the term using the respective formulae. Is how we do using splitting the fractions. Now let's see some problems based on trigonometric functions. Now basically, when we solve integration of trigonometric functions, we need to understand the concept of trigonometric functions which are learned in the concept of trigonometry. Most of the formulae which are discussed are again revisited when we do integration. Say for example, I take the problem where I want to integrate the function sine square x by 1 plus cos 2x. dx. So let's see how we can integrate this function. So let's recap with some of the trigonometric formulae which I learned in the previous session to do the integration of trigonometric functions. So when I have integral of sine square x by 1 plus cos 2x, we know that 1 plus cos 2a is 2 cos square a. Is 2 sine square a, is how we understand the two concepts of 1 plus cos 2a and 1 minus cos 2a. Now, we have this as sine square x by 1 plus cos 2a, which is 2 cos square a. Therefore, 1 plus cos 2x is 2 cos square x of dx. Now, 2 is a constant. Therefore, I can bring it out, which comes as 1 by 2 of sine square by cos square. Now, we know that sin x by cos x is tan x. Using this formula of the sin x by cos x is tan x, I can write this as sin x by cos x whole square of dx, which reduces to tan square x dx is how we get. Now we know that 1 plus tan square theta is secant square theta. That implies I can split tan square x as secant square minus 1. So this reduces to secant square minus 1 of dx using this formula 1 plus tan square is secant square. Now splitting this, we get integral secant square x dx minus integral of dx is what we get. Now we know that integral of secant square x dx is tan x plus c. As we have seen in the standard formula, integral secant square is tan x plus c. So therefore, I get this to be tan x minus x plus c. Therefore, integral of sine square by 1 plus cos 2x dx is tan x minus x plus c. So this is how the trigonometric functions are integrated using the respective formulae we have in trigonometry. Trigonometric functions connected with integration.